go.
Hello!
Hello, Mr. Ari, are you alright?
Yeah.
Okay, so can you tell me what's palindrome? Remember we talked about this a few while ago? Palindrome. What's palindrome?
When you reverse it, it's the same.
Okay, can you give me an example? Can you give me an example?
Race car.
Race car.
Brum, brum.
Why is race car a palindrome?
Because,
This equals this, yeah?
Yeah.
This equals that. This equals that. Yeah? Alright? Yeah? And it can be even number or odd number, right? It could be something like E-R-R-E, right?
what's error?
No, I'm just making things up. It's
You
right,
can do poop.
Ooh. Or B-O-B, bop, okay? Yeah?
No, do poop.
P-O-P?
Yeah.
What does it mean?
Poop.
Okay, that's it, okay.
Poop is.
So do you still remember if we given a string or a list? Yeah? A string or a list, how do we check if it's a palindrome? Remember? How do we check if a list or a string, a list or we call it array? How do we check if a list string is a palindrome?
Reverse it.
Well, yeah, one way will be reverse it. So how can, if we S is a list or string, how can we check? Return reverse it. S equals how can we reverse this bit?
Color minus one.
Yeah, this is the one Python way to do it. And another approach is what? How do we do it? How do we do it? Look at my hand. Look at my hand.
2 pointers.
2 pointers. So I equals 0, j equals the length. Yeah, the length minus 1. Okay. While I smaller than j, right? If si not equals sj, return what?
False.
False. And then I plus equals 1, j minus equals 1, right? That's the 2 pointer thing, yeah? Got it? Yeah?
Yeah.
Actually, there's another way, third way, is that if we calculate the index,
How many ways are there?
quite a lot, but this is the most typical 3 one. Okay, so
Typical.
look, Eric, if this index is 0, what's the opposite at the other hand? If this is, how many characters is it? 2, 4, 6, 7. 7 characters. If this is 0, what's this index? 7 minus 1 minus 0, okay? If it's 1, what's this index? 7 minus 1 minus what?
1,
Yeah. If this is 2, what's the index? 7 minus 1 minus...
2.
Yeah, that's it. So we just compare index I with what? N minus 1 minus I, okay? And then we just compare these, right? Until the middle. Yeah, we just need to come from I from 0 to N divided by 2, yeah? We just need to go into the middle, yeah? We don't need to go further, right? Am I right? Got it?
Yeah.
Okay, so you understand this complexity is all O(n), right? Okay. So how about the linked list? We want to check if a palindrome is a linked list. What's the difference here, Eric? What's the difference? If a list and
A linked list,
what's the list? What's the difference between list and a linked list? List, linked list.
A linked list has numbers in circles.
Yeah, that's visual. Yeah, that's how we visualize it, right?
And connected by lines.
Connected by line. Okay, so list, look, this is list. 1, 2, 3, 4, right? This is the list. And the linked list is 1, point to 2, point to 3, point to 4. Okay, so this is how we represent it visually. So list is that the memory is the continuous, right? So
It has commas.
this is continuous. So in memory, Eric, you'll be just like that, Eric. These are together 1, 2, 3, 4, right? So it's continuous. If we know this position of the 1, Eric, we can calculate 2 and 3 and 4. Yeah, the computer knows how to get the value of 2, 3, 4. Yeah, it means the access is O1. or 1 complexity. But for this one, it's not, right? I mean, look, the 1, 2, 1 and 2 are not it could be, it could be different, right? So it could be at different positions. So it could be somewhere else, somewhere else, right? It could be, it could be, what's the word? Sparsely allocated, different way, right? This could be as, yeah, am I? So how do you represent this? It could be, yeah. No, it could be 5. So at each node, you will be a value, and then you will be a next. Anyway, next. So what? We need the overhead to store the next position, right? Am I right? That's the pointer to the next. Got it? So this one, you'll be only storing 4 values, right? But this one, we will need additional next pointer to point to next. Why? Because the next one is not on its next. It could be somewhere else. So what does it mean? If we want to get the value 3, we don't know yet. We need to traverse from the beginning, yeah, followed by the 1 to the 2 to the 3. So what does it mean? What's the time complexity of getting number 3? O(n), where down? Because we need to travel from the beginning, yeah. Yeah. When the travel, that's the difference here. I just touch your list, okay. So what's?
He pokes me.
Yeah. So how is that different? I mean, so we can we apply the algorithm, the previous algorithm, alright? Can we apply the previous algorithm?
Maybe we can.
The 2 pointer we can't, right? Because we only know the beginning here. We are not, for example, the 2 pointer thing. Yeah, 2 pointer thing. We don't know the end, right? Alright? And each node only points to the next. It doesn't point to the previous, right? Unless it's a 2-directional pointer, yeah? 2-directional linked list. So meaning this way, right? Alright, can you listen to me?
I am.
Okay, so can you repeat what I said?
So it can go to the it doesn't go to the previous one. It can go all over. Yeah.
So so for the 2 pointer, we need to know the beginning and the end. And also, in order for the 2 pointer to work, the node has to point to the previous node as well. But for this single linked list, we only point to the next one, right? It doesn't point to the previous one. Then how can we apply this? Any idea? One obvious example is how.
Brute forcing.
Yeah, how can we brute forcing?
Checking every possibility
Of what?
of doing those stuff.
What stuff? What stuff?
Brute forcing.
How can we brute forcing? What do you mean by brute forcing? Come on. What's the difficulty here? We know how to check if an array or a string is palindrome, but we want to apply the same techniques on the linked list. So how can we do something to do what? To apply this algorithm?
Sort it.
What do we?
I mean, split it.
Sorry, break it.
Break it.
Break it what?
Split it into.
Yeah, we can split it, but what I mean is that, is there a way that we can transform the linked list to the list, so then we can apply the same techniques, right? Yeah? Oh yeah, that's very obvious to think about. We know how to check a list or an array is a palindrome. And then if we want to check the linked list, the first thing to do is to what?
To make it into
a linked list.
Yeah.
To a list, yeah?
Yeah.
Okay, so let's do it.
Number 4.
Come on, Eric, you need to tell me, okay? Define, let's say check. Let's say root.
Column.
Okay, so how can we what do we need to do?
We need to.
What do we need to do now?
Start.
What do we need to do? Come on, what do we need to do? What do we say? What do we want to do now?
We need to
This is the node.
Oh.
Let's say node. Node. A node.
Look, node.
So-
Node.
Yeah.
Sounds like noob.
So node. What should we do with the node?
We need to is node the what's the node?
The node of the like there. That's the node here. At the beginning, the node is here.
Oh, we need to move it. We need to change it into link. No, list.
Okay, so should we define a list?
Yeah.
Okay, so let's say data. Data equals, how do we define a list?
Brackets.
Bracket, okay. And then what we want to what? What do we need to do now? We want to walk through the, yeah?
We want to walk through the thingy.
Okay, so wire,
Oh yeah.
Wire
Walk
data.
through the thingy.
wire what? Wire node, actually. Wire node, what should we do? What should we do with that? Wire node, what?
We
Wire node is not the end, it's not the long. Wire node is not the end. What should we do now? We should do, what should we do?
move.
We should do what? The value, we know the value, we should do what? Come on,
We shall move to the next one.
move to the next one. How do we move to the next one?
Plus one.
Node equals what? Node. Dot. Node equals node over what?
Dot next.
Yeah. But move to the next. What? Before moving to the next, what should we do? We have the value. What happened to the value? Node of value.
You need to
What?
change it into
Change it to what? Node of value. What happened to the node value? I'm currently a node, and I have node of value. I know already node of value, and I'm jumping to the node of the next one. But before that, what do I need to do with the value?
and put it in the data.
So how can I do it?
Data equals no,
Data to what?
dot
To what?
append
Append. Yeah, come on. Append. Append what?
node dot value.
Okay. So here, what do we have? The data is the list, a list representation of the linked list. So we want to check how. Then what's next? Yeah. What do we do next?
Oh, we need to
Return what? Come on. You can write it. Return what? Come on. We check. We convert the node into a data, and we want to check the node if it's a linked palindrome. So what should we check now?
if data colon 1 song
Equals data. Yeah.
colon 1 song.
Okay, that's it. We're converting the node to a data, and then we check the data instead. What's the time complexity for this one?
Oh.
Oh, what?
And
Okay, what's the space complexity?
what's T for?
Time.
Oh.
What's the space complexity?
Um,
Come on. If I ask you the space, check for any space we are allocating.
1 ON.
Why is ON? Don't look at me, look at the code. Come on.
I
What's the-
am.
Yeah, why is the code? Why is the space we're allocating? Yes, this data stores the copies of the values. Yeah, that's it. Okay, so let's first way. Okay, it's easy. Yeah, for the linked list problem, we convert it to a list problem, right? And we already know how to apply the algorithm to check a list if it's a palindrome. Okay, so remember, what's a stack? What's a stack? Remember, what's a stack?
It's normally, yeah, you
What's the stack? First
then last out.
First in, last out. Yeah.
Below.
So if look at if this is 1,
Below,
Two,
below,
3, 2, 1. If the linked list is here, right? So if we travel list, remember previously we put in the list. Yeah, if a list can be used as a stack. Look, if we put this into a list, a stack. So it's what? 1, 2, 3, 2, 1, right? Alright?
1, 2,
Yeah, 1,
3,
2, 3, 2, 1. And then we work again from the beginning. So by here, I work it in the beginning. I take one out and check if it's the same. If it's the same, I move it to the next. I take one out. It's the same. I move it to the next. Take one out. Take one out. I take one. Okay, then it's a palindrome. Yeah, got it?
I don't.
You don't get it?
I don't understand. Wait.
You don't understand? We work through.
Wait. So you fill it up with all of this.
Yeah, and then we work through from the head again, and then we take it from the end. Yeah, a stack. Yeah, got it?
But we walk through the stack.
Yeah.
So we're like, this is the same. This is the same. This.
Yeah. Look, this is the opposite order, right? You see? So if your parents are in the opposite.
Oh yeah.
Oh yeah, yeah. Got it?
Yeah.
Okay, let's write this. The second approach, okay? And remember, at the end, I want you to write one approach, at least one, okay?
Oh, I don't remember. I don't.
At least you tell me how to do it, okay? Come on. Remember?
All I think I know is, I think all of the others are gonna be super long.
No, look, this is easy. Look, check note, okay? Now we use a stack.
Then return.
Stack equals
Oh.
a list, yeah? We can use a list as a stack, okay? Come on.
Yeah.
And then wire no. This part is the same. So
While no.
Yeah, and what?
We shall pass.
Wire no, what should we do now? We want to put it in a stack, so how can we
Put
do
it in
it?
the stack.
Yeah?
Put it in the stack.
Okay, so add what?
Put it in stack.
Tell me how to write it, come on.
Okay.
Ah.
So we stack
St dot
append
append what? Node of value.
Node of value node.
And then what's next? Node equals what?
Node of next.
Node of next.
Node of next. Node of node.
Okay. But in the beginning we need to store a copy of node, yeah? Let's call it head equals node, okay? Because we are changing the node here, okay? Now head is beginning now, so what should we do now? Wire head. Then what? Now we want to compare the head and the top of the stack. So what's the top of stack? This is ST. What's the top value? How can we get the top value? If the top of value is head of value, head of value, if it's not equal to top of value, yeah? So what's this? What's this? This is ST. What's the back of ST? Come on. This is ST0. This is a stack this way, yeah? So what's the last element of ST? ST what?
-1.
Yeah, ST minus 1. If it's not equal, return.
False.
Okay. Now, what should I do with the head? Head equals what? And then ST what? And then return what? Come on. Can you tell me? I want to move.
Return true.
Yeah, return true here. So what happened to the head? Head is at the beginning. At the beginning. I want to go to the next one. Head equals what?
Head equals head to next.
Yeah. And then what happened to the stack? Stack, this is stack minus 1, and I want to remove it. I want to take it out. What should I do? ST dot what?
Pop.
Yeah, that's it. What's the time complexity?
That's a long one.
No, you're not remembering. You need to understand the approach. That's it.
Okay,
What's the space? What's the
head equals node.
What's the time complexity?
ON.
Oh,
Space complexity.
but we are going through the linked list twice, right? All right? Yeah. The first pass is to place a node into the stack. The second pass is comparing, right? The time complexity. What's the space complexity?
ON.
ON. Okay. That's it. And actually, we have two more approach. Okay. Look.
Are you kidding me?
Come on.
Oh.
Look at this is the
Bowling.
look, Eric. This is the linked list, yeah. 1, 2, 3, 2, 1. So how can we get the middle of it? Remember we talked about this. How do we get the middle node of the linked list?
We use that. What was it again?
What? How do we do it? Can you? What?
I think it's the rabbit and the turtle.
Rabbit and turtle. Yeah. Rabbit and turtle. Yeah, rabbit.
The one which I was very good at. And the
Okay,
funniest.
rabbit and turtle. So
And the funniest. It was like
okay,
this-
so how can we find? Can you explain to me that how can we use the rabbit to find the turtle?
Okay, rabbits.
Rabbit and turtle is
Rabbit twice as
twice.
fast as turtle.
Okay, so fast and slow pointer, yeah. So fast rabbit walks 2 steps at a time, and turtle walks 1 step at a time. So look, my right hand
Wait,
is yeah,
it does twice.
yeah
as
2
much.
yeah. Look, my right hand is rabbit, my left hand is turtle. Okay, okay, let's go. Look,
Let's go.
2 step, 1 2, 1 step, 2 step, 1 step. But it can't jump to the 2 steps, so that's the middle. Slow, the turtle will be the slow. So why are we wanting this middle? What do we do with the middle?
Oh, because I don't know.
What happened to the middle? Why do we need the middle thing? What happened? What's the palindrome if we break
yeah.
it into middle?
If we break it into middle, both sides need to be the same.
No. Look, not exactly. One more step. 1 2 3 2 1. If we break it in the middle, so 1 2 and 2 1. So if we reverse this bit, then it will be the same as the first
Yeah,
bit.
that's exactly
Okay,
what I
okay.
said.
So we break in the middle and then we reverse this bit. Okay. Let's try this. Okay. Define. Let's just check. Note. Okay. Fast equals slow equals note, right? At the beginning, they are pointing to the first one, right, Eric? Okay. While
Fast equals slow
fast.
equals no.
and fast to next, yeah? Because it needs to move 2 steps at a time. So what should we do? Fast equals what? And slow equals what? Come on. Fast is equals what? Slow equals what?
No.
Sorry?
No.
Fast equals slow equals no. At the beginning, they are pointing to the first position. Okay. This is fast.
Fast equals no.
Sorry, fast equals no. No, fast equals slow equals no. So at the beginning, the fast needs to walk 2 steps at a time, right? So what should I do with this? Fast equals what?
Fast equals 2 spaces.
2 base what? How can we move 2 steps? Fast. What's
Plus 2.
the linked list? Fast. What's the next of fast? What's the fast? This is fast. What's its next?
Fast plus 1.
This
No,
is the linked
plus
list.
1.
This is linked list.
0.
Linked list. What do we do with the previous one? While no equals no dot what?
Next.
Yeah, fast equals what?
No dot next.
There's no note. Fast equals what? Come on. This is
Fast dot next.
yeah. Fast to next.
I know it is right there.
Yeah, but I already set it to fast. Okay, fast equals fast to next and
Slow equals slow dot next.
so fast it needs to work one more step. So how can I put this? Fast equals fast to next dot what?
Dot next.
Yeah. Come on. How hard is
Fast
that?
dot next. Fast dot next dot next.
That's why
Fast
look.
dot next dot
Why
next.
fast is not none and fast to next is not none. We want to move 2 steps at a time, okay? So now slow is the middle, right? Alright? Yeah? And then we want to revert, break it and look. Okay, look Eric. Okay, so here is previous one, yeah? Here this is slow here. Okay. And then now I want to look at what I did. I want to reverse this bit, break it and reverse this bit, make it this way, right? Make it this way, yeah? Alright? I want to reverse this direction. Yeah?
Yeah.
Can you stop doing that? So at the beginning I will have a right equals none, and now we have while, slow, and I want to save this value first. P equals slow dot next, okay? And then what? And then slow dot next equals right. Yeah, I want to point it to back, right? And then what should we do now? P equals slow down next. I want to, this is no, P will be equals to here. And then slow down next is here. I want to point to the previous one, right? Which is none. So I will remove this and then here will be none, right? Right? And then I want to move this.
Slow equals none.
This is P, this is slow. And slow equals P, right? Slow equals P.
P.
And
P.
is it slow? No. Actually, it's right. Right, the previous one will be equals to slow. And then slow will be equals to P, am I right? So right will be slow, and slow will be P, right? Am I right? So in this case, we're reversing that. Right equals slow, slow, we are reversing that.
It's free time.
Okay, so Eric, right, Eric, do you understand this? Okay, I'm going to do it one more time, okay? Look. Right equals none at the beginning, right? This is slow. Slow equals. Yeah, I want to reverse this bit. How can I reverse this bit? First of all, I save this value into P, yeah? So I know this is P here. Right? Look, and slow down next equals right. Can you tell me what's this? Slow down next equals right. Slow down next, I'll remove this, equals right. Here, look. And right at the beginning will be none, right? And then right equals no. Right will be equals no. Right is here. And slow equals P. Slow will be equals P. Right? So slow will be equals P. And at the end, look, at the end it will be slow to next, and the next iteration will pointing this way. And the next iteration will pointing this way. And at the end, the right will be, which node will be the right at the end? Which node will be the right at the end? Which node will be right at the end?
Slow.
1, 2, 3, 4. Which node will be the right at the end?
This is right.
That's the beginning. And right, look at it, and then right equals no. Which one will be the right at the end?
Does right move?
Yes, of course. Right equals no. Look here.
So is right the slow?
Yeah.
So in the middle.
And then slow will be moving to the P, slow down next. So where at the end of this loop, why is no? Which node will be right? Come on, I'm just asking you. Which node will be right?
1 and D2.
Why? Why slow? Slow will be moving to the end.
No.
So which one?
Fast.
Sorry?
Fast supposed to go to.
No, I'm talking about this one. Do you understand what this is mean? If you understand, then you know what's this bit. This is at the beginning. This is slow, and what's this doing here?
It's right equals none.
Yeah.
While slow, P equals later.
Next, yeah, and slow down next equals right. So you're pointing back. Right equals no, and slow equals P.
Facing this way.
Yeah, it's changing the direction to this way. So what happened to the right at the end? What's the value of right at the end? No, but right equals slow. You're moving this way. Come on. So what's the right? Come on, obviously. Yeah, that one, the beginning. So that will be the, because this is reversing, yeah? So at the end, the right will be the linked list. So what should we do now? What should we do?
We shall
What should we do? If I say left, I have a left equals no. So what should we do now? With left and right. What should we do?
we shall
What should we do?
swap.
No, you're not swapping. So remember what happened to this linked list? 1, 2, Eric. Like, if we break it into the half, Eric, what we did is breaking it into the half and reverse this bit. So look at E 1, 2, 2, 1. And now reverse this bit. That's right, yeah? Then there will be 1, 2. So what should we do with now? This is right. Huh? Eric, right is here. And left is here. What should we do now? Come on, it's quite obvious. Come on.
We shall reverse it
I already reversed it. Reverse it. 1 to 2.
and checking if it's the same.
Yeah, checking left and right if it's the same, okay? So, okay, I'm going to erase this and then left, right, okay? So that's the easy part. While left and right, right? If left dot value not equal right dot value, what should we do? If left dot value is not equal right dot value, what should we do? Return what?
But
Return false. And then what should we do with the left and left equals what and right equals what? Come on. What? And then return what? Come on, tell me.
left dot next.
Left equals left dot next. Well done.
Right equals right dot next.
Yeah, and then return what?
True.
Yeah, we're just comparing left and right, yeah. Why is that? Because we already break it into half and reverse the second half. So the second half is start with the right. Yeah, the first half is starting with the left. With the note. Yeah, I was just comparing. Yeah. What's the time complexity? What's the time complexity? Oh, and what's the space complexity? Are we using any space here? This approach? Do we use any space? We just
One.
Oh, one. And we are not using any space, but the thing is, we are modifying the list. Yeah, we are making changes to the original list. Am I right? Yeah. Okay. Okay, the last approach quickly. We're using recursion. This is more advanced. Okay. So define, check. I'm going to write it. Okay. No.
Node. Why?
Okay, so-
Why do we call it node?
If it's a tree, that's a root, right? Tree has a root. If a node, linked list is node, just one direction. It doesn't have a root, right? Got it? It's just the naming convention.
A node
Okay.
sounds like a noob.
So at the beginning, node, I will set it to the beginning. Okay, so look. Okay. So the thing is that if the thing is the target is that if I want to compare the palindrome is that I want to compare this node which node which node are we
Last
com-
node.
the last node and this node I want to compare with which node.
The second last.
Yeah, we're done. So look, we can use the recursion. Yeah, let's call it recursion. DFS node. Right? If not node, we just return true, right? Okay, then I have an answer. I will check the next one, which is DFS node.next. And then root will be equal root at the beginning, root.next, and then I can return answer. That's it. Okay, I'll tell you later. Okay, then I can just return DFS node. That's it. You see? It's really simple. Look, here I need to add the access to this node, so I will add one non-local. Okay, that's the syntax. You need to add a non-local root, so it knows that when we change this bit, it's changing this value, not the scope inside this value. So it says non-local root means that this root is here, not inside here. Okay. Alright. So look, this is the recursion. Right? If the node is nothing, return true, right? An empty node, a linked list, is it a palindrome? Yes. Yeah. Okay. Then now I will check the next one. But when this is recursion. When it calls it, so at this point, you calls it itself, Eric calls it until it reaches the last point, last node. And when you reach the last node, right? You wanted, okay, so there's something missing here. So I want to say, if...
Wait, so root.node goes here?
No. Root at the beginning is node. Okay, so I have to check it. If root.value is not equals node.value, and I want to return false here, yeah? I want to return false. So I will go to the next, and then what's the root value? Is the beginning, yeah? What's the last value? That will be, the node will be, after recursion, the node will be last value. And then the root equals root next. So okay, I'm going to check this. Okay, I tell you. Okay, so look, root equals node at the beginning, right? Alright, and then you call this root on recursion, not next, and then you will be calling stack, you will reach the last point, right? Then you will check if root value equals node value. If it's the same, if it's not the same, you will return false. Otherwise, root value will go to the next after recursion, right? Right? And then this comes back, it will be the previous one, right? Until it, yeah? Does it make sense? The time complexity is still O(n). The space complexity, because we are using the recursion, is O(n), right? Got it? Yeah? This one is a little bit more advanced. The problem is, why this works is because there's a stack. It's like a stack. And where is the stack? Is this recursion. It's the recursion. Because every time we calling the recursion, right? Every time we calling the recursion, when this goes to the end, right? You stop here, goes to the end, and you will come back. You'll come back. You're calling stack, you'll come back, right? Got it? Okay? Okay, so I have talked about 4 approach. Can you write a 1? Just 1, simple one.
Oh.
Define, check root, okay? Node, okay? Can you write any one? Come on.
I don't know what.
Anyone. That's it. Anyone will be fine. What's the first one? I review it. Convert it to a list. Yeah? The second one, using the stack. The third one is a more complicated one. I hope you're not choosing that one. Find a meter, break it into the meter, and then reverse the speed. That's too much work.
The fourth one.
The fourth one, recursion. Do you understand? If you don't understand, you can write it. So I will think the first or
I
second
just
one.
don't know how to start.
What?
I don't know how to start off.
Start what? Okay, tell me which one you understand, and then I help you.
I'm just gonna choose a random one.
Okay, go. It's your show time. Come on. It's your show time. Come on. Come on, it's your show time. Yeah?
Whoopsies, I drew on my finger.
That's okay. Come on. Come on.
I don't know how to start off.
What do you mean? Which one? Which mixer you pick? Which one?
I don't know which one to pick.
The first one, maybe? Convert it to a list. That's the simplest one.
Simplest.
Yeah? You just convert a list. What happened? If we want to convert it...
We just... Well, okay. Wait.
Okay, let's try a list. Yeah? How do you define a list?
Wait, let me... Which one is suits for me?
Come on, the first one or second one? Second one is a stack. Yeah, we walk through the linked list and put it in the stack.
You said the fourth one was advanced. What does that mean?
Advanced means it's difficult to understand, and it's not required if you don't write it, and because it's harder to understand.
Is the second one with a stack?
Yeah, stack. Yes.
Is it like this?
Yeah, it's a what? What's
Is
this?
it head?
Head is this is the third approach.
Oh.
Okay, we had the third approach. We breaking into the half, right? But the stack just you can use any name to declare a stack. Okay, come on. Let me Erica. Let me data. Let me whatever. Okay, come on. Write it. Start writing it.
Okay, fine.
Okay. Yeah, write it.
I'm doing
Okay. Well, whatever. Yeah, whatever. How? Come on. Whatever equals what? Come on.
whatever equals a list.
Okay, a list. Yes, well done. Okay. Yeah, let's well done. Keep going, and then we want to put it into the list. Yeah. Come on.
Put it in this.
Yeah.
Whatever dot append.
Yeah, and then we need to
need
walk through the list. Yeah. How
No,
can we?
I called that something.
That's okay. Just why? Come on.
Okay.
Taking what time?
Whatever dot append.
But at the beginning, you need to iterate until it reaches the end, right? How can you?
Okay.
The wire
Whatever
keyword.
dot next.
Wire.
While whatever.
Wire
While
node.
node.
Come on, wire node. Because wire node means that the node is not empty. Yeah. Wire node. Yeah. Wire node. Yes. Okay, column. Yeah, and what should we do? Put it in the linked list. Come on. What should we do?
Whatever the append.
Yeah. Okay.
Whatever.
You need to indent. Come on. Have a space in the beginning when you start with the while column. Okay. Whatever the append, know the value. Come on. Write it. Yeah. Come on. You see? You name me whatever. You need to write more. Dot append.
I didn't care.
Okay. Then dot append. Come on.
I like to sit here all
Okay.
day.
Append. Append.
Oh.
Come on. Come on. Append.
Node.
No.
It's better if I can name node poop.
No dot value. We want to append the no dot value. No.
Oh, then.
But actually, you can append no, but you need to write more later. Not the value. It's a value. It's an integer. Okay. And then what happened to the node? If we put this node into the stack, whatever, this is a stack or list, yeah. And what happened to the node? We want to what?
Go to the next one.
Okay, so node.
No, here,
Yeah. No.
dot,
No equals. Come on.
no dot next.
Yeah. Come on. Okay. And then I have whatever. You want to use it as a list or you want to use it as a stack?
We want to use it as
Using the list will be easier. Using the stack.
List, that's
Okay.
fine.
Then whatever.
whatever.
It's a list. You want to check if it's a Palindrome. How can you write it?
We
We already know that, yeah, the Python way. How can we write it? Come on.
can write whatever,
Return whatever what?
return whatever.
Whatever what? Equals what?
Return
Yeah.
here,
Yeah. Uh-huh. Whatever.
whatever,
Oh, come on.
whatever.
What? How can we write it? Compare if it's equal what? Equal what?
Whatever.
Uh-huh. We want to compare if it's a Palindrome, so how we write?
Ever.
Yeah? Wow, you remember this. Nice. -1, not dot 1, okay?
I did.
Okay, that's it.
See?
That's it for today. Say bye-bye.